Assalamualaikum and good day, guys. So today we are going to proceed on how to solve a Fourier series. Okay, but before that, let's just recall back on sketching the graph. Okay, so let's consider this kind of function here. Okay, so quickly for this one, for this function, so this is symmetrical about fx axis. Okay, this is fx axis. Okay, so this is symmetrical about fx axis, so therefore symmetrical about fx axis, so therefore this is an even function. Okay, so the next one, this function. Okay, so as you can see, this graph here is symmetrical about the origin. Okay, so symmetrical about the origin, therefore the function is an odd function. Okay, and the last one here, let's consider this function. Your fx is equals to cos x, and another one is fx is equals to 0. So as you can see, for this function, this is not symmetrical, either f-axis or x-axis. Sorry, it is not symmetrical either f-x-axis or origin. So therefore, this is a neither function. Okay, some books use y-axis, some books use f-x-axis. So you just refer to your textbooks. Okay, so just use f-x-axis. Okay, so I hope by now you are able to distinguish whether the graph is odd, even, or neither function. Okay. Okay. The last graph here. Take a look at this graph. Okay, cos function and sine function. Okay, so for this function here, this is an even function. Why? Because it is symmetrical about fx axis. Okay, symmetrical about fx axis. So therefore, a cosine function is an even function. Okay, for this sine function here, as you can see, it is symmetrical about the origin. So when you have down here, then you will have up here. Okay, it is symmetrical about the origin. Therefore, a sine function is an odd function. Why it is important for you to distinguish whether the graph is odd, even, or neither function? Because when we are going to solve the Fourier series, the way to solve it is different. If your graph is an odd function, then you will have to use this formula. If the graph is an even function, then you have to use this one, and also for neither function. So it is really important for you to really know whether the function is odd, even, or neither function. Okay, so as you can see here, we are going to use this one for you to get the Fourier series expansion for the function. Okay, so what is a naught, an, and bn? So a naught, an, and bn is called a Fourier coefficient. Okay, a naught, an, and bn is called Fourier coefficient. Your Fourier series expansion will be given by this function. Okay, the Fourier series expansion is given by this function. Okay, so the only difference is on how to get the a naught, an, and bn for odd, even, and neither. But for you to write the Fourier series expansion, you are referring to the same formula here. Okay, as you can see, this is your fx here, the Fourier series expansion. So if the function is an odd function here, a naught and an is equals to 0. So this one is equals to 0, an is equals to 0. So therefore you left with this single function. Okay. For the even function, your bn is equals to 0. Okay. And you need to calculate for your a naught and an. Okay. So therefore when you write your Fourier series expansion, your bn is equals to 0. So you don't have a value here. So you just left with a naught over 2 plus the summation of this function. Okay, but for the neither function, you need to calculate all a node, an, and bn. Okay, and as you can see in this formula, for odd and even function, you are considering 2 over L, and your limit is from 0 to L. Okay, as you can see, for odd and even function, you are considering 2 over L, and your limit is from 0 to L. Okay, but for the neither function here, you are considering 1 over L, and your limit is between negative L to L. So I will explain in detail uh, in my next example why this one you need to consider 1 over L and your limit is negative L to L, while for odd and even function you are considering 2 over L and your limit is from 0 to L. Okay, so now take a look at the first function here, the first example. We are going to try to solve the neither function first. Okay, so let's say you are given a function fx is equals to, so this is neither function. Okay, fx is equals to 3 and another one is 3x over pi, and the limit is negative pi x 0 0 x pi for fx is equals to x plus 2 pi. Okay, so the first question, so please refer to your notes. Okay, so the first one you were asked to sketch from x greater than negative 3 pi until 3 pi. Okay, so I really hope by now you are able to sketch the graph, because I already showed you many examples in my previous video. Okay, so as you refer to this example, so this is a constant, so you don't need to do a table of coordinate here. So you just need one table of coordinate, which is for this function. Why? Because you have the variable x here. Okay, so by considering your x is equals to 0 and x is equals to pi, and your fx is equals to 3x over pi. So when your x is equals to 0, then you will have 0 here. When your x is equals to pi, then you will have 3. Okay, so your coordinate will be 0 0 and another one is pi 3. Okay, this is your x. Okay, so if you plot the graph of this function, so as you can see here, they are using the range 0 negative pi to 0 0 to pi. Okay, so I'm using pi, 2 pi, and another one is 3 pi. So this is x-axis. Okay, on the left hand side you will have negative pi, negative 2 pi, negative 3 pi, and this is your f(x)-axis. Okay, and your fx is equals to, so let's consider this one 3. Okay, this is just a sketching. Okay, so for the first function here, from negative pi to 0, your fx is equals to 3. So therefore you will have a straight line here. Okay, from negative pi to 0, your fx is equals to 3. Okay, for the second function, so you need to plot the coordinate here. So the first point is 0 0, which is here. The second point is pi 3, which is here. Okay, so therefore you will have this line. Okay, and the graph repeat itself after this period of 2l, which is 2 pi. Okay, so therefore you will have another straight line. So you stop here, then you need to start the new one here. Why? Because you have a straight line here. Okay, so you have this one here, and you start at 2 pi down here, and you will have this one. Okay, and for your left hand side here, so this is function 1, this is the second function. So on your left hand side, you need to start with the second function. So since you stop here, then you need to start here. So for the second function, you will have this line here. Okay, and the first function, you will have a straight line here. Okay, so as you can see, this graph, this is not symmetrical, either the fx axis or the origin. If this is symmetrical about fx axis, you will have a straight line here. Okay, not here. If this is symmetrical about origin, if you have this line, then you will have another one down here. Okay, so that's why this is a neither function. Okay, so the second question, you need to identify whether the function is odd, even, or neither. So clearly this is a neither function. Why? Because it is not symmetrical about origin or fx axis. So now, since this is a neither function, so for you to get the Fourier series expansion, you need to use this formula. Okay, so what is your L here? Okay, there are two ways on finding your L. The first one is, remember the definition that I told you in my previous video. This one, fx is equals to fx plus 2L. Okay, and what you have is fx is equals to fx plus 2 pi. Okay, so for the second one, this is another function. So for the third one, so first you need to identify your L. Okay, the first step is identify your L. Okay, so you have the general is fx is equals to fx plus 2L, and what you have is, for this periodic function, you have is fx is equals to fx plus 2 pi. Okay, so by comparing these two, so you know that your 2L is equals to 2 pi, so therefore your L is equals to pi. Okay, it is important for you to have the right L, because you are going to use this L. Okay, so if the value of L is wrong, then everything will go wrong. Okay, so please be careful. So back here, another way of finding your L is, so this is the first way, by comparing the general one with what you have here, and another one is by looking at this range here, the original range here, you can get directly your L, the last one here. This is your L. Okay, so you have two ways of finding your L, either by using this one, okay, or just take from the range of x, the last one, okay, the greater one, the greatest one, okay, the greatest value of x for your function. Okay, so in this periodic function, so your L is equals to pi. Okay, so if you take a look at this one, why for neither function here we are considering 1 over L, negative L to L? Because based on your graph here, the graph is not symmetrical, either fx axis or origin. So you need to consider each of these function. Okay, so that's why you need to consider from negative L to L. You need to consider both function here, because the function is not symmetrical. Okay, so first we are going to get, so first one you settle with your L. So the next one is on how to find your A node. Okay, so your A node is given by this function 1 over L from negative L to L fx dx. Okay, so what is your L? Your L is equals to pi. So you will have 1 over pi, negative pi to pi fx dx. Okay, take a look here. Negative pi to pi. Okay, which means from here to this point, from negative pi to pi. As you can see, you have two functions here. This is your first function. This is your second function. So you need to split this one according to your function here. Okay, to make you easy, you can just refer to this one. Okay, the original one is from negative pi to pi, which is from negative pi to pi. Okay, but your problem now, you have two functions. Okay, so you need to split this one into two functions because you have two different fx for different range. Okay, so therefore you will have a naught is equals to 1 over pi, so bracket, so the lower limit is negative pi. So take a look at your function here. Okay, this one, x greater than negative pi less than 0. So you are considering this first function first. Okay, x greater than negative pi less than 0. Okay, so therefore you will have negative pi to 0. Okay, negative pi to 0, x greater than negative pi to 0. This is lower limit, this is upper limit. Okay, so from negative pi to 0, then what is your fx here? So fx is equals to 3 dx. Okay, plus, so another one is from 0 to pi. Okay, what is your fx? Okay, we are still referring to this one. Okay, from 0 to pi, then what is your fx? So your fx is equals to 3x over pi dx. Okay, so originally, okay, you need to integrate from negative pi to pi. Okay, fx, but your problem now is you have a different fx for different range, so that's why you need to split the function. Okay, and you have this one. Okay, so solve this one will give you, so a naught is equals to 1 over pi, so integrate 3 with respect to dx will give you 3x, 0 to negative pi, plus, so the second one, so 3 over pi is a constant, so you can factorize 3 over pi. Okay, so integrate x will give you x squared over 2. Okay, so your limit will be from 0 to pi. Okay, so then what you need to do is apply the limit. Okay, upper limit minus by lower limit. It should be upper limit minus lower limit. Okay, so you will have, so if you substitute 0 here, then you will have 0 for the first one, minus, so for the second one, when your x is equals to negative pi, then you will have negative 3 pi. So settle for the first function. Okay, for the second function here, plus 3 over pi, so substitute, when your x is equals to pi, then you will have pi squared over 2 minus 0. Okay, then simplify what you have in the bracket first. So 1 over pi. Be careful with this 1 over pi because this 1 over pi need to multiply by the whole function here. So that's why I'm using this big bracket. Okay. So solve what you have in this bracket first, then you will have 3 pi plus, so this one you can cancel out, then you will have 3 pi over 2. Okay. So if you expand this one, then you will have 3 plus 3 over 2. Okay. Therefore, you will have 9 over 2. 3 plus 3 over 2, which is equals to 9 over 2. So therefore, your A node is equals to 9 over 2 because this one can cancel out and this one also can cancel out. Okay. So the next one is finding your AN. Okay. So the third step is finding your AN. Okay, so what is your AN? The AN is given by 1 over L from negative L to L fx cos n pi x over L dx. Okay, so what is your L? So you just need to substitute back your L here. So you will have 1 over pi from negative pi to pi fx cos n pi x over your L is equals to pi dx. Okay, take a look at this one here. The difference between A node, AN and BN, as you can see, for the front part here is just the same. Okay, but for A node, you just need to integrate fx with respect to dx. But for your AN here, your fx need to multiply by cos n pi x over L. Your BN here, your fx need to multiply by sin n pi x over L. Okay, so you still need to split this function into two because you are referring to a different fx for the different range. Okay, just like we did for the A node. Okay, so I will just use start here. Okay, so this one I already split. This is your fx. Now your fx need to multiply by cos and x. So therefore your an is equals to 1 over pi open bracket. So the first one is negative pi to 0. This pi to 0. Your first function is 3 multiplied by cos nx dx. Okay, plus, so the second one is 0 to pi. So the function is 3x over pi cos nx dx. Oh, I remember something. Okay, when you split your function, remember the general one is negative pi to pi. Okay, so negative pi to pi. So you need to make sure you have the same value for this one and this one. Okay, if not, your limit is wrong. This is your lower limit, this is your upper limit. Okay, and this point must be the same. If the upper limit is 0, then this one, the lower limit, must be 0. So that's why for your AN here, again, you need to integrate from negative pi to pi. Okay, from negative pi to pi, and you have the same value for this one. Then only this is correct. Okay, that's how you check whether you are doing the right thing or not. Okay, so the next step is to integrate. So you don't have any problem to integrate your left hand side here, but you have a problem to integrate this one. Why? Because you have a multiplication of two functions. That is polynomial here, and this is trigonometric function. So here you need to apply tabular method. The only technique of integration that will be used uh, in this chapter is tabular method or by part. But I always ask my student to use tabular method. Okay, much more easier. Okay, for this one you don't have any problem. This is direct integration.